Okay, everyone, and welcome back to AP Physics. Hopefully the last 2 days you got your feet under you, figured out what was going on, how we're going to do these things, and we're going to, hopefully I got myself figured out as well. So, here's what we're going to do today. We're going to do some practice problems. These are the problems we didn't quite get to. You have the packet of presentation problems. Those I will put the answer keys out there for you. So please take the time to finish up the presentation problems. That's going to be part of today's assignment, is finish the presentation problems, and then the couple of practice problems here. And that'll finish up our time for today. So here we go. Here we've got a couple of parallel wires carrying a current. You've got a wire on the top up there carrying 6 amps, the bottom's carrying 3 amps, and it's looking for the net magnetic field at points P1, P2, and P3, which are equally equidistant between the two wires. Redrawing it from the end might help. It'll let you know whether things are going into the board, out of the board, that kind of thing. Once you've done that, then you want to calculate the force on the bottom wire. Let's assume the wires are a length of 8 meters. At this point, pause the video and give those a shot, and then we'll continue. All right, so here are the answers for those previous questions. You've got your 1, your 3, your 2. The numbers are obvious, they're on the screen. What you need to take into account is the top wire, its magnetic field at those locations is into the board. The magnetic field from the 3 amp wire, those are out of the board. So you did have to figure out their individual magnetic fields using the mu naught I over 2 pi r formula. But because they're opposite directions, you had to take the difference in their values. In order to get the force answer, you would need to find out what the magnetic field is from the 6 amp wire at the location of the 3 amp wire, so it's a distance of 4 meters. Once you've got that magnetic field, then you've got your filled, you've got your 3 amp wire in the magnetic field to get that force. I noticed that in my answer here, I did not give the direction. The force should be upward, because the force would be attracting the two of them. Again, right-hand rule, magnetic field from the top wire is into the board at the location of the 3 amp wire. So if you use your right hand, your fingers go into the board, the current for the 3 amp is to the right, so your thumb would be to the right, so your palm would be upward, showing an upward force on that 3 amp wire. Okay, here's our next practice problem. And we've got a 4 amp wire carrying a current to the right. We have another 4 amp wire 3 meters below it, and that's carrying a current into the board. So we want the magnetic field at location P0. So that one you may have to think through a little bit. Again, looking at it from another direction, maybe from the top, might help just a touch. Once you've got that answer, second question, what is the force on the bottom wire created by the magnetic field from the top wire? Again, pause the video, give those a shot. Alright, so this one's a little different direction than almost anything we've done before. So, since you've got the top wire creating a magnetic field into the board, again, right-hand rule, thumb along the 4 amp wire, fingers wrapped around it. So, you've got the magnetic field into the board there. The bottom wire, that would be, again, right-hand rule, current into the board, magnetic field to the right. So at point P, you've got a field going into the board and a field to the right. And since they're the same magnitude, it ends up being at a 45-degree angle into the board and to the right. So we're 45 degrees behind the board, off to the right. Yeah, it's a weird reference frame. Probably not something you'd ever see on an actual AP test. But again, the idea is how can we look at these things differently? And hopefully, without doing any math, you recognize that the force on the bottom wire would be 0 newtons because the wire is going to be parallel to that magnetic field and therefore have no force on it. Alright, one last question on this one. Here we've got that same setup. So your magnetic field is at 45 degrees into the board over there. Here we take a positive charged particle traveling through point P, coming out of the screen, so towards us, and we want the force on that particle traveling at that speed. Now, yes, it's probably going to curve and other things are going to happen, but we don't care. We only care about right this instant in time. What is the force acting on it? Pause the video, give that one a shot. right, so of course, finally, here's the answer to that one. You've got your force on a charge in a magnetic field. That's going to be QVB sine theta. But since the charge is coming out of the board and the magnetic field is at a 45-degree angle to that, you're going to have to multiply by that sine of 45 to get that to work. So there's your final answer. And of course, direction. Kind of weird. You got to put your fingers for the magnetic field at that 45-degree angle. The particle coming out toward you, you have to break your thumb to pull that one off unless you're double jointed. But then you'll still see that force with your palm is up. Okay, so between this and the answer key, which I'll put out there as a PDF, please remember, these answer keys are to old AP questions. I'm sure they're out there on the internet somewhere. I'm not supposed to post them online, but I think considering the situation, the conditions here, I have no choice. So I'll put them as a PDF out there. Keep them close to your chest. Don't re-upload them anywhere. I'm allowed to hand you a printed copy, so this is close enough. We'll make this work. I hope you guys are doing great. I really do. Things are awfully quiet around here. Think good thoughts for those who still have to go out there and work. My wife's a pharmacist, so she's out there on the front lines. So I'm sitting around the house alone, making these videos, hoping you guys are all taking care of yourselves. You know, this whole social distancing, there's a lot of articles out there on it. Read up on them. I just read a math one where it talked about the numbers doubling every day. And think about the math of that. If you take a number, you double it, you double it, you double it, you double it. That exponential growth is really what they're trying to prevent. So please listen to what they're saying. Don't go hang out with some friends just because, hey, it's just my buddies. It's okay. It's just spreading the vectors out. We've canceled a bunch of things this week ourselves. So stay safe, stay clean, and we'll hopefully see you guys in a couple of weeks. Take care. Hey, one more thought. If you have any questions, need help with anything, please, 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 please feel free to send me an email. I'm here alone. Emails are my only contact with the outside world right now. And honestly, I'd probably rather have email questions from you guys than sit and watch yet another really bad TV show. So please, if you have any questions, give me a shout. I'm happy to help you out. All right?